In this lesson, we're going to be learning about lookup tables. In survey solutions, we can use lookup tables to import a large amount of external data into our questionnaires. External data means data that we've got from some other source. It's not answers to previous questions in the survey. Now, given we're in the advanced course now, we'll be doing quite a tricky example involving crop density, where we'll take the plants per acre of various crops from a lookup table, and we'll combine this with the ternary operator that we learned about back in lesson 1. Let's start now by taking a look at lookup tables and how they need to be formatted and set up. So the purpose of using a lookup table is to bring some external data into our questionnaire itself. External data means things other than the previous survey responses. So the problem we're going to solve in today's lesson, and this is common in a lot of agricultural surveys, is that depending on the type of crop and the size of the holding, respondents might be able to better or only report back to us the number of trees or plants, or in terms of the amount of land which has been planted. So we're using a lookup table consisting of crop density factors. This is how many trees are usually planted per acre for each crop type, to normalize out reportings in land or trees and plants. We're doing this because it'll be useful for analysis or for further validations. So if we're gathering, for example, the total land size of the entire farm, but we're only gathering some of the crops in terms of the number of trees or plants, we need to be able to turn the trees and plants back into their equivalent acres to make sure that things aren't being over-reported. Let's shift across to the designer tool now and have a look at how we've got this set up. So working in lesson 5 and lookup tables, what I've set up for us today is, first of all, a multi-select question, which contains all of the different crops and their codes. From this, we build a crop roster out, and the first question inside asks whether the respondent can answer in terms of the size of the land planted or the number of plants or trees which have been planted. After this, we have questions 2 and 3, and they will depend on if we're reporting back in number of trees or in number of acres. Now, after this, I've got a couple of variables, so I want to convert and normalize back into the number of trees and into the number of acres. The next thing to talk about is how our lookup tables need to be formatted so that survey solutions will accept them and be able to work with them. So the first rule is they must be saved as a text.tab format. The second requirement is that the first column should be titled row code, and it contains only unique integer values. So no decimals and no value twice. The other columns, you can add as many as you'd like, and these can be named whatever you like, and they can contain repeating or even decimal numeric values. So here's a quick example below. Our first column is the row code, and it's got unique integers, so nothing is coming twice. And the next column we have is plants per acre, PPA, and this is different values for each one, though these could be decimal if you required, and they could be the same for different crop types. So here I have the Excel spreadsheet for the data that I want to import into survey solutions. You can see I've got the name of the crop, its code, and the usual plants per acre. Now, the first thing to note is that our crop code used here needs to be matching to what I put in survey solutions. So you can see here, Amartheus 201, avocado pear 101, and etc. So back here where I've set up my multi-select question, you can see we're using the same codes for the same crop. Very important that these two lists are consistent. So the next thing to do is to format this file so it can be accepted by survey solutions. So first of all, we don't need this column at all. The name of the crop is stored back here in the designer tool for us already. So we can remove this column. Now, as we said, our first column, our lookup value needs to be called row code. And this one can be called anything I like, plants per acre. So what we'll do is do a file save as, and we need to change the type to a tab delimited. Once our tab delimited file is set, we'll come back to Designer and press on this icon here, which is for the lookup tables, and then press to add a new one. Now we've got two fields here. First of all is the name that we give to the field. So I'm going to call this one density. And we need to select the file we'd like to upload. So here's my one I prepared earlier. And you can press save and then compile to make sure no problems with it. So now that we have our lookup table correctly formatted and uploaded into the Designer tool, it's time to take a look at the syntax that we'll have to learn in order to extract the right pieces of information from our lookup table. The syntax that we'll use to pull data out of the lookup table looks like this. We start with the table name in pink, and then within the square brackets here, the value, and then a full stop, and then the return value. So to run through each of those components, first of all, the table name is what we named the table when we imported, not the file name itself. The value is the row in the table that we want to access. Now, when working with rosters, this is usually the @row code variable. And finally, the return value is the name of the column that we want to return the piece of data from. So we'll begin here with the variable plants. And what I want to do is take the answer from question 3, the number of acres planted, and then multiply it by the value from our lookup table for that particular crop in order to give us the equivalent rough number of plants. So the expression is going to be, first of all, the lookup table name, which is here, and it's this pink text density. Next, I open the square brackets, and I'm going to be looking up the row code of the current roster row. After the square brackets, we need what we're going to return. So the column name to return from my Excel file is this one. I called it PPA. So we'll put PPA. So that will return the value from this one for the relevant row code. What I then want to do with these values is multiply them by question 3, the number of acres. So to take a quick test, I'm going to take banana crop first of all, our third one down. And what I'll do is put in the size of the land. So let's say that it's perhaps 5 acres. And we're accessing our lookup table and spitting out the correct number of plants. To double check that, we'll come down to bananas, the third one down. It should be 674 times 5, which will give us 3370. Now the problem remaining is if I opted to put into plants and put in 1,000 banana plants, this does not yet appear here in our normalized plant variable. So we'll go back now and add a ternary operator to put either this value or this converted value into our variable. So to start our ternary operator, we're going to say for this variable, if Q1 is equal to plants, so if Q1 is equal to 2, then we're going to put into this variable the answer straight up from Q2, so the number of trees as reported by the respondent. If it's not 2, if it's equal to 1, then we're going to move to our density conversion. So with our updated code, we should now be able to enter our answer in either land size or plants and have it come back out with a normalized variable for plants. So we'll just test land side. We've got 2 acres of banana, and that gives us the approximate plants. If I enter in plants itself, 1,000 plants, we will receive 1,000 plants in the variable as well. And finally, we've set up a similar expression to convert the number of plants or trees into acres. So again, our ternary operator asking if Q1 is equal to land size, then we're going to use directly the answer from Q3, how many acres. If it's not, then we're going to use our density value, and instead of multiplying it, we divide it by the number of plants or trees entered in Q2 to give us an approximation of the land size in acres. So there's our lesson on lookup tables. It's a really important skill to master so that you can bring data which is external to your questionnaire into your questionnaire. I hope you'll use it in the future because bringing this type of real-world data into the survey can really strengthen your validations and lead to better data quality.